In this example, 34.3, we are dealing with another curved mirror. And in this case, we have Santa Claus looking in a Christmas ornament that's reflective. And the Christmas ornament, is an example of a convex mirror. So what we are looking at here is the mirror, instead of like in example 34.1, the mirror is kind of bowed out like this, okay? And our image is in front of the mirror. I'm sorry, our image. I always swap that. Our object is in front of the mirror, aka Santa Claus. And he happens to be 0.75 meters away. Okay, so that's going to be our S, the object distance. And the diameter of the ornament is 7.2 centimeters. So we can figure out that the radius is 7.2 centimeters over 2. And the height of Santa, okay, is 1.6 meters. Go ahead and write everything in meters. Well, let's write this in meters. So 7.2 divided by 2, and convert that to meters. That's going to be 0.036 meters. So you can choose if you rather do everything in centimeters. That's totally fine too. I just prefer to use meters. So anyway, what are the questions here? The question is where? So what is S prime? And how tall, Y prime, is the image of Santa formed by the ornament, right? And this ornament here is a convex mirror. Is it erect or inverted? That's basically answering the question, is Y prime greater than 0 or less than 0? Okay, so we're going to use our good old object image distance relationship. We'll go ahead and use the version with R. And so we want to figure out what S prime is. So we need to plug in a value for R. And so since our mirror is convex, our R will be negative, okay? So convex means R is less than 0, and that's because the radius of curvature is not on the same side as the ray. So here we're gonna put in negative, let me get white, negative 2 over 0.036 meters. That's gonna equal 1 over our object distance plus our unknown. So this becomes, mental math, not the greatest here, a little more difficult, but it would still be possible if we really wanted to do that. So I get negative 55.6 inverse meters. I'm gonna subtract 1 over 0.75. Okay, so when I subtract these two, I'm going to get negative 56.9 inverse meters is going to equal 1 over S prime. So S prime is basically 1 over 56.9 with a negative. Which comes out to be 0.018 meters. Okay, so about 1.8 centimeters. So what is 1.8 centimeters? That is how far away the image of Santa appears to be from the mirror, okay? So that's why Santa looks like his nose is magnified, and you know, like this is Santa's image, right? So his nose is really close to. It looks like it's really close to the mirror, right? To the surface of the ornament. Looks like it's about 1 centimeter away. It's close. So let's continue on. So we found S prime. And now we need to find Y prime, which is the height of the image. And judging by this picture, we should expect Y prime to be positive because the image of Santa, which is what is shown here, is upright, right? It's not inverted, it's upright. So we should expect Y prime to become positive. So let's see if we can make the math happen. So if we want to find Y prime, then we need to use the magnification equation because that's pretty much the only equation that brings you Y prime. Now we have this guy and this guy, and we know this guy. We know this guy, so we're going to find Y prime. I'll go ahead and do that over here. This was part A. Oh, it's not A and B here, but we'll do that over here. So the magnification, well, it's going to equal negative S prime. S prime was negative 1.8 centimeters. And I guess I'm going to do this in centimeters now. Our S is given to us as 0.75 meters. So that is 75 centimeters. See, my brain isn't used to working from meters to centimeters. It likes centimeters to meters better. And that should equal the image height, which is what we're solving for, divided by the object height, which is Santa's height, which is 1.6 meters. And I'm leaving this in meters here because you see the centimeters cancel out over here. And so then what I can expect my answer to be is in meters. All right. So the left-hand side, we're going to do 1.8 over 75. And that gives us 0.024. That's going to equal Y prime over 1.6 meters. So I solve for Y prime, which is 1.6 times 0.024. That comes out to be, and this will be meters, 0.038 meters. Okay? In other words, 3.8 centimeters. And that is going to be Santa's height, his image height in the ornament. Okay, so this was kind of like a word problem, and you had to sort of understand that if we're using a sphere as a mirror and we're looking at the sphere from the outside, the mirror is essentially a convex shaped sphere, right? Because the reflective surface is this bowed out surface here. So, so that covers this example. We'll do some more examples in the following videos.